Hello! Hello, everybody, and welcome to the LIUniverse. I'm Dr. Charles Liu, your host, and if by now you haven't yet, please call me Chuck. It's a real pleasure to have you here today, and this is going to be a great episode. We're going to have lots and lots of cool answers to questions, and maybe new questions too, that audience members have been giving us. This is sort of a year-end fun party time that we're going to have. And as always, it is such a pleasure to have as our co-host, Alan Liu. Hey, Alan, how's it going?
Hi, it's going pretty good.
Okay. Have you been involved in any interesting manufacturing processes lately?
Very specific.
Yeah.
Yeah. So I mentioned on a previous episode I have a 3D printer. I 3D printed a new stand for my microphone. So that's the one I'm
Oh.
currently using. So if it sounds bad, it may or may not be my fault.
I love it. This is wonderful. Okay, well, I'm glad to hear it, and it's always good to know when technology produces something better in our daily lives.
Yeah.
That we will now go, as usual, as always, to today's joyfully cosmic cool thing. So today's cosmic cool thing is a picture. It often is, of course, but this particular picture is, as you might imagine, from probably the coolest telescope that's currently out there right now, the JWST. All right. Yes, JWST is it's hard to believe, right, Alan? It's been up for almost 2 whole years now. It's
Yeah,
quite
yeah. We got
amazing.
the first images about a year and a half ago.
Yeah, and but now it continues to amaze and it's working even better than the original design specifications. The most recent picture that has come from there is of the planet Uranus, or Uranus, the seventh planet in our solar system, right? Oh, as counting out from the sun. There's
Yeah.
a beautiful, beautiful photo. See, because Uranus is so cold, it's best to take a picture of it not with visible light, but with infrared light. And that's exactly what the JWST specializes in. And so early on, there was a picture of Uranus right at the
Mhm.
very beginning, right, on the early releases in the first year. But now a picture has come in, which is just amazing. It shows 7 rings. It shows 14 moons. It is just incredibly beautiful. Have you
Yeah.
seen this picture, Alan?
I'm just looking it up right now. If I
Hmm.
remember, Uranus was the second planet they discovered rings around. Saturn's are the biggest and brightest, but Uranus, I think, was the second. And on,
That's
we
right.
later found out all the gas giants have rings,
That's
and
right.
maybe some little comedy things might have rings too. So
Right. Pieces of rings also,
yeah,
really tiny things. You just every time I look at these new pictures, it's really quite
it's
remarkable
very
what new
impressive.
stuff it shows. So it's very, very impressive. So that's just super cosmically cool. If you guys get a chance, go take a look. It's an amazing picture, and the 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 moons around it, because JWST is taking these images with infrared light, they almost look like not just moons, like little tiny dots, but entire worlds. It's.
Yeah,
I think it's
yeah. I
totally
mean,
amazing.
yeah, they are. When Voyager 2 spotted them, they're really impressive places.
Yeah, I think that's super super cool. So um, let's get right to those questions, okay? All of you in the audience, just so you know, uh, we get questions regularly from you all, and we always try to answer a few questions in each episode. And those of you who are Patreon patrons get first priority in getting your questions answered. But all of your questions are important to us, and we really appreciate it when you ask them. So today, as a sort of end of the year fun thing, we're going to answer a whole bunch of questions as if you were typing into me I don't know, some artificial intelligence answer question bot or something.
Yeah,
So we're going to call this episode Chuck GPT.
yeah, yeah.
We're going to have a great time with it. And
No
because
guarantees if
we,
that's the title that you'll see on the podcasting app, but it's at least what we're calling it.
that's right. And to bring the questions to life, we are bringing on members of the LIUniverse production team. And here are they, two out of the many people that do all the cool stuff that make this podcast possible. Benji and Stacey. Hello, Benji and Stacey.
Hello, Chuck and Alan and Stacey.
Hello.
Hi guys. Hey everybody.
Hey. you
Hi.
know, I don't get a chance to thank you guys often enough on the air. during the show for all the things that you do to make this possible. I mean, I'm just a guy who's talking into a microphone, sitting in front of a camera. It's the rest of the stuff, all the other things that are being done that really make this show exist as it does. And so I want to thank you guys. Today I get a chance to thank you too. Over the coming episodes and the coming season, I would like to thank even more of you in questions, in Q&A type question episodes of this kind. But right now, thank you so much for being here, and I really appreciate your being here. Thank you. Benji, can you introduce yourself a little bit? Tell us what you do in general, what you do for the LIUniverse.
Absolutely. My name is Benji. I'm a part of the social media team with Stacey. My main job is uploading and managing our TikTok account, which isn't easy because we get questions on there sometimes, and I'm not a scientist, nor am I knowledgeable about science in general. So it's a bit of a challenge, but I make it work somehow.
No, you do. You are more knowledgeable about science than you let on, Benji. I know the truth. And you're also especially, I'm most impressed by the record collection that is behind you right now. Those of you who are just listening to us and you don't see the video, Benji is displaying for you a very impressive vinyl collection there. Do you have a favorite piece of vinyl that you like to display or highlight or tell us all about?
Why, yes, I do. One of the many records I have in my collection. This is a signed copy of Paul McCartney and Wings album "Band on the Run." It was signed, but not signed by Paul. Signed by the late Denny Lane. Denny Lane just passed away last
Oh
month.
my goodness, that's
Wow.
right.
And I got this from him. I saw him live back in February with my dad.
Wow.
And
Wow.
it was so cool to meet him and get this signed. And it's been on my wall since then. And it's a wonderful album. He was a really nice guy and one of my favorite musicians. And
that is
That's
amazing.
awesome.
And Denny Lane, such a classy guy. He was one of the original members of the Moody Blues
yes,
way back. And then he left. But later, he still very much supported them and was very kind to everybody, very happy to see them succeed. And then Denny moved on with Wings and other kinds of projects. Tremendous, tremendous person.
he actually did sign my copy of the Moody Blues album. Also, it's in the show.
Oh, wow.
Really?
Yeah, he did.
Fantastic. Holy moly. Wow, Benji, that's incredible. We
Thank
will
you.
come back to your collection sometime soon, I'm sure, because
Absolutely.
there's great stuff to talk about. Thank you so much for doing what you do for the LIUniverse. Thank you. And Stacey, please introduce yourself too to our audience.
Hi, everybody. I'm Stacey.
Hi.
I'm usually behind the curtain on these things. I'm at every recording session, kind of typing in the background, making notes and telling people they should be louder and things like that. But I manage the social media communities on Facebook, Instagram, and Twitter, X, and Patreon as well. So, not only bringing you clips of our shows, but content about science in general and those famous videos of Chuck singing and interviewing other scientists and stuff. That all comes from this little room that you see right here.
Oh, it's wonderful.
Really appreciate it. Yeah.
Thank you so much, Stacey, for everything. I really appreciate it. It's been wonderful, and we've had such a good time doing this show and the whole LIUniverse channel. Thank you so much.
It's such a joy. It's such a joy.
I love it.
Thank you, guys. So let's get right to it. I mean, hopefully we'll have a bunch of questions. I'll just sit here and with a little luck, we can make this whole thing work out.
Yeah, let's go for
It
it.
reminds me of a song.
I caught that.
I'd better take off like a band on the run before you guys catch up to me.
Okay.
Oh, man. All right. So do you want to jump into the questions?
Go for it. Tell me who and tell me what.
Okay, I'll jump in. Our first question comes from YouTube listener Darker Void Scientist, who asks, wouldn't some violently spinning galaxies produce strong magnetic fields that could act as a barrier to some spectrum of traveling waves?
Very, very good question. So thank you, Darker Void Scientist. You do explain correctly that when you have a spinning system, which has some net electric charge, you wind up creating a magnetic field. And it can be magnetic forces that can affect the motion of objects going in toward or out of the spinning system. So in this case, you're saying that if a galaxy is spinning very, violently, then it might produce a magnetic field that could block some waves and so forth. Well, first of all, it won't block electromagnetic waves, that is light, as much as you think. It can cause electromagnetic effects. For example, something very famous called the Zeeman Effect, where you can actually change or adjust the colors of the
That's a
light that's
fun
going
name.
through it.
Zeeman Effect.
Zeeman, a Dutch guy who won the Nobel Prize a long, long time ago. Yeah, it's a lot of fun. So it can happen. Usually what happens is that the light will be distorted but not blocked. But objects can be blocked. For example, dust particles sometimes can be moved. There is something called the Parker Instability, not so much about rotating magnetic systems, but where magnetic fields might actually be able to prevent or otherwise affect the motion of dust particles in and around a galaxy. But most galaxies don't spin quite so violently as to be able to do a whole lot of that, right? Remember, the galaxies are really big and they spin, although in terms of absolute speed, it's pretty quick. It takes them a long time to go around once. So our Milky Way galaxy, for example, where we are orbiting the center of the Milky Way, it takes 250 million years to go around the center one time. Yeah.
So we've only gone around like
18.
18 times.
That's right.
Yeah.
That's
wow.
right. We are galactic teenagers.
That's
here
amazing.
on Earth. Yes, which I think is
not
kind
humans, like the Earth itself.
That's right.
Damn.
The Earth itself. Yeah, which is so
that
long.
You're making me feel young, Chuck.
And we're galactically able to drink in all countries except for this one.
Oh, yeah, that's right. No, but see, the magnetic field prevents you from being able to go to the bars. Because Milky Way does have a bar, as you know.
It's a barred spiral.
That's a barred spiral. That's right. Where violent spinning actually has a significant effect is near the centers of galaxies, where there is a supermassive black hole. When it's spinning so violently that you can have tremendous effects, create jets that are moving at a high fraction of the speed of light. You're throwing off a lot of heat, a lot of material, and then you have these corkscrew magnetic fields that can go for literally millions of light years. So great question. Lots of deep, cool science built into that kind of thing, spinning magnetic fields out in space.
All right.
So let's go on to the next one.
Yes, so we have another question, also from YouTube. Mark Caesar 4443 from YouTube asks, when stars go very near black holes and get slingshotted around them, what would we see of them in terms of time dilation? Surely we would see them slow down as they approach the black hole. Of course, that is assuming we could actually observe them.
Terrific question. It's a little bit hard to see time dilation from an external source as it comes close to the black hole, right? Remember, we are seeing it doing unusual things, but it is the star itself experiencing the dilation. So what we're watching is actually not that distorted. What we would see is that a star coming close to the black hole, because it is an extended object, will actually be ripped by the tides of the black hole, so that you'll get a stream of material coming out. Now, the material right near the event horizon of the black hole, assuming you could see it, like you said, good point, will be gravitationally redshifted. So the colors will be distorted toward longer wavelengths of electromagnetic radiation. Toward, for example, if you were blue object, it would look reddish, or infrared, or even microwave, radio wave, that kind of thing. So you would have a distortion in the color, and that's what you would see more than a distortion of time, because there's no clock that you can watch slow down, for example, as it gets closer to the event horizon. So it's a visual effect rather than a time effect that you would most likely see.
Yeah, we do see time dilation with stuff where there is some sort of built-in timing thing, like with muons coming through the Earth's atmosphere. That's speed time dilation instead of gravitational. But because they decay in a certain amount of time, you can see that time stretch out for them. So that the more of them hit the ground than you'd otherwise expect.
Right. That was actually a very important confirmation of the special theory of relativity. Before we had good laboratory equipment to be able to confirm what's going on, these objects should have decayed in our atmosphere before they reach the ground. But because of the time dilation they experience moving so close to the speed of light, they actually live longer, and so they can reach the ground. And then there's the other direction where what's happening is that they see our Earth's atmosphere as being less thick. They travel a shorter distance because of the Lorentz contraction.
So from our perspective, their time is slowing down, and from their perspective, the atmosphere is smaller.
Yeah, which is super cool.
It's wild.
It's a neat lesson to learn. Yeah, in modern physics classes, it's super cool. Although, I say that I personally feel that the term modern physics is now a little bit of a misnomer. A lot of physics undergraduate degrees have this class in there called modern physics, which bridges electromagnetism and quantum mechanics. There's got to be a better way to call it now, because that quantum physics is 100 years old now, and the modern physics is even more than 100 years old.
Well, that's also it's like modern art, right? Where modern art is an era of art as opposed to the art that's happening now, right? It could be the same idea.
Or modern music. I mean, Stacey, you play music. Would you consider modern music music from 1905?
Well, now they call it 20th century music.
See, that makes sense. Right? Seems logical.
And we're in a new millennium, but I'm still stuck on muons. I'm thinking about cats on the internet. What's that all about?
Muons, they're like electrons, but heavier, and they decay over time into electrons. But it does sound like little cats on the internet. That does, in fact, sound like what it is.
Meow, meow, meow. Oh, yeah. That sounds like fun. Okay, thanks. All right, great question. What's next?
All right, so this is one that I can answer. This is from Randy Starnes on Facebook, and Randy asks, can we take a rechargeable battery and use it to power a plasma rocket? I guess this must have come from when we were talking about plasma rockets an episode or two ago.
Yes, that's right. We have Ad Astra Corporation, right? Franklin Chang Diaz and Miranda Chang. Yeah.
So for a plasma rocket, the amount of energy you need is like so much more than you could reasonably fit in a battery to last that long. So batteries probably wouldn't help very much with plasma rockets just because you can't get all that much energy in a rechargeable thing. But rechargeable batteries are useful on rockets more generally. Rocket Lab, which is a New Zealand and American rocket company that makes these little rockets called Electron that go send tiny little satellites to orbit. They use electric pumps on their engines. So one of the biggest challenges with an engine is actually getting the fuel into the rocket engine, because the rocket exhaust and the chamber in which the combustion is happening is at such a high pressure, which is what makes the rocket go, that in order to push something into it takes a huge amount of energy. So most big complicated rocket engines use a bunch of pumps and smaller engines to like force the fuel in. But Rocket Lab basically figured that for the size of rocket they were building, and for the era which they were working, when batteries, have gotten smaller because of electric cars and things like that, that they could just have a lithium-ion battery on their rocket and then just run a really powerful electric motor to run that pump.
Whoa! So in fact, using electric car technology, basically, we're putting it on rockets, and it's useful. Not exactly the way that the questioner is asking, but actually very useful.
But still very useful in a very, very cool way. So that's pretty helpful.
I love that. So is the latest version of Kerbal Space Program allowing you to put an electric pump on there?
I think they haven't modeled that specifically. But I've been playing a set of mods that lets you do stuff like that. So,
okay. Well, let's see how it goes. Let us know if it works, and then we'll tell the Rocket Lab folks how to do it.
Yeah, well, they're the ones that they're telling the Kerbal people how to do it.
Oh, even better. Okay, next question. Oh, yes, go ahead.
Question, maybe stupid from the layperson here.
No, don't ever say any questions.
Oh, Stacey, I'm the layperson here. Please go on.
Well, I like to know that there are no stupid questions, but I do wonder. I'm curious if you can't bring a lithium ion battery on an airplane.
Yeah.
Why put it on a rocket?
On a rocket filled with fuel. Like,
well, it's already exploding anyway. It's like
it might explode at the wrong time, right?
That is the thing. If it burns up at the wrong time, you have a problem. I think basically the calculus is sort of like there's so much else on the rocket that also could burn up at the wrong time that if you're having enough safety features to make sure those things don't burn up, then you can also do it for your batteries. I think that's how it goes.
Yeah, that makes sense. I mean, your average lithium-ion battery is a small one, like say that you would put in a
Cell phone or
I was
something.
gonna say Walkman, but I guess that would be a little bit on the old side.
Yeah.
A little lithium ion battery on a typical cell phone or something like that, right? Those are not that dangerous unless
Yeah.
they're made poorly,
Right.
and
Yeah.
that's the risk that airlines don't want to take.
Right.
I think
Yeah.
it's simple as that.
Makes sense.
Cool. Thank
Yeah.
you, guys.
No, that's a great question.
Yeah,
Though. That actually
definitely
really is.
happy to answer.
Yes. Okay, next question.
Okay. Looks like this one is coming also from YouTube from SB Carrion. How do NASA or anyone measure distance from the planet to the sun? I heard for Earth they measure the distance to Mars or Venus transit using Kepler's third law. Is it the only way?
Great question. Historically, when we were all as human beings stuck on the Earth's surface, yes, using the transits was the right way
Yeah.
to make these distance measurements. But it all has to do with trigonometry, right? Being able to see things and know what angles which objects are when they're at these different locations relative to the Earth. Today, we are much better equipped. We can send satellites up. We can do interferometric observations. We can do different kinds of things that make the transit methods much older than necessary. We don't need to use those transits anymore in these modern times.
Yeah, we have radar too. I know is a thing that people do.
That's right. You can even bounce a radio signal off of another planet. Now, bouncing radio signal off the sun is a little bit harder because it's itself a very, very powerful radio source. But nowadays we can even measure distances to other stars. Not just our planets, but far, far away. The Gaia mission, for example, being run by the European Space Agency, has literally mapped 1 billion plus stars in our part of the Milky Way galaxy. And they've measured how far away things are with very, very high precision. We're doing 3-dimensional tomographic measurements of the structure of our Milky Way galaxy. Yeah, tomography. Yeah, it's some pretty cool stuff. So that's a great question. And it's a neat way to sort of think about how our knowledge of science has gone from early trigonometry to like the modern times where we can do all this in space.
Gaia is still using trigonometry, right? Like
that's
just
right.
On an even bigger scale than the Venus transit things.
Super trigonometry.
Yeah.
Trigonometry.
Yeah.
All right, next question.
Yes, the next question is also from YouTube, from Frank Westfall 8532. What would happen to the other star in a supermassive star binary system if one of the stars supernovaed before the other?
Great question. This is actually something that happens literally all the time.
Oh,
yeah,
that's great.
Very often you have a star system that has one object go supernova while the other one isn't. One of the most standard kind is literally being used as a standard candle, right? It's called a type 1a supernova, where you have a compact object like a white dwarf, and then you have a non-compact object, and the material from the non-compact starts flowing onto the white dwarf, and it reaches a critical mass, and then that white dwarf goes supernova. What happens to the other star, right? Now, that other star tends to be obliterated.
Oh, dang.
Yeah, but it doesn't have to. It could survive under a wide variety of circumstances, or at least the core, if it has a strong, dense, degenerate core, could survive. And it gets kicked. It gets pushed kind of in a weird way because the explosion is very, very powerful, right?
Yeah.
So you do see evidence of these objects, which might have been former stars or stellar remnants, just moving away from what look like supernova events at astonishing speeds or in strange directions that would not be consistent with a typical orbit of a star in a galaxy. And that probably is the cause. That's where one star in a binary system goes supernova and the other is caught in the blast.
Well, that's a great, but he has a follow-up. Frank has a follow-up, an even
okay.
crazier question.
Uh-oh.
Oh,
Okay.
yeah. Could early universe supermassive star binary systems experiencing a supernova with one of the stars have accelerated the creation of supermassive black holes by causing a premature collapse of the star that didn't supernova and therefore creating a supermassive black hole with a combined mass right from the start of both the supermassive star's leftover cores?
Whoa.
Oh,
Making
right.
my head
Whoa.
hurt.
There's,
Ah!
there's,
That's a
there's a
vision.
lot
So,
of supers. Yeah, that's a
So you-
super question.
so
Wow.
So the idea here would be you'd have two stars, one goes
Yes.
supernova, and then it like eats the
Causes
other one.
the other star.
Yeah.
No, it causes the other star to
Oh,
go
causing
supernova.
the other star to go
Yeah,
supernova.
and then the two of them come together, right?
Come together.
It right now. That's right.
Nice.
Now, I would say that that is a plausible scenario, but it's hard to know how often that happens. Frank, you've put your finger on one of the great mysteries of current stellar evolution theory, and that is what happened with the very first stars. We're pretty sure that many, if not all, of the first generations of stars, only a few million or a few 100 million years after the Big Bang, were very massive, hundreds, even thousands of times more massive than our sun. Right? Modern day stars, in the current time, we see very few stars that are more than 100 times the mass of the sun. So these are really gigantic stars. We don't know enough about them and their physics to know, for example, how long they would last. That if they did go supernova, would they leave a black hole? And if they would, how massive would that black hole be? Would it be also hundreds of solar masses, or would it only be a few? And then, with the amount of energy being released in that supernova explosion, would it be a disruptive event? In other words, tearing a star into pieces that's nearby? Or would it actually be like a stimulative event causing a premature collapse of its core? Right? So, um, I can't answer your question definitively. All I can say, Frank, is that it's possible. And stay tuned as my colleagues who are really good at this computational astrophysics, stellar evolutionary theory stuff keep working on their models. We might figure out some super solutions to these supernovae and causing supermassive black holes to be super speed produced. To be produced at super speed? Yeah,
Yeah, probably that. That's
superb.
Cool.
Yes,
That's awesome.
That was a super question. All right,
Well,
zipping on. What's the next? Yeah, go ahead.
I was gonna say, Chuck, if you can't answer that question, it makes me feel better about my lack of stuff.
Believe me, there are so many questions I can't answer, and that's a good thing, right? I would be bummed if I could answer every question, because then, like, I'd have to make up new questions to answer.
Well, that's not too bad.
What keeps
Well,
us curious?
That could be fun. Yeah.
Right?
Yeah, well, but then you would soon be in a state where you could no longer answer every question, I guess.
Oh,
because
I
then you
hope
would have new questions.
That's right. Because every new question, yeah, right. Oh, this is getting into serious logic stuff now. Oh,
right.
that would be fun.
Philosophical
Can
craziness.
humanity ever get to a point where it knows so much that it can answer questions faster than they can ask them?
Ooh, I
we
doubt
make
it.
We may get to that point, but even if we did, there'd still be plenty of people who wouldn't even want to or couldn't know everything.
That's
Yeah,
true.
fair.
I think
Humans.
Barkley on the holodeck could.
Oh yeah,
Yeah.
yeah. Let's get some Star Trek folks in there.
Well, I don't have a Star Trek folk, but I do have some wonderful folks from the All Things Unexplained podcast.
Oh, I love those folks.
Yes,
They're so
Dr.
sweet.
Mouse and CJ. We love them, and you know, Chuck has been lucky enough to have been a guest on their podcast many times. And just a shout out to the great people on All Things Unexplained. Put that on your download list. Put it on your download list.
Yeah,
listener.
totally.
Okay, so and we just love them. Hey guys, CJ, Dr. Mouse, this one's for you. Here's their question from Instagram. When will astrophysics encounter / present undeniable proof of a new life form?
Oh, new life form, not just evidence of the existence of life that we don't know about, like extraterrestrial life, or like
Well,
definitive
I
evidence.
imagine any extraterrestrial would have to be a new life form, right? Because it wouldn't be exactly the same as anything on Earth.
That's true. Unless like some bit of DNA got thrown out of the Earth's environment a long, long time ago and like drifted and survived,
The
landed on.
panspermia hypothesis.
Yeah, something like that, you know?
Yeah,
You
well,
could
that's
imagine it.
possible. But even then, it would. I mean, okay. So, I mean, I know my soonest possible and latest possible answers.
Oh, okay. Go for it. What do you think?
All right, my guess for soonest possible answer is when we finally land on somewhere like Europa or Enceladus, which, I mean, they're working on a Europa lander now, hypothetically.
That's true. That's true.
So I feel like there's at least a reasonable chance that something down there is some sort of little archaea bacteria blob.
Wow.
But I don't know. We can wait to see. And my latest possible answer is maybe we're the only ones. I mean, that would be a little sad, but
yeah.
I'd love to see more life out there, but there's no guarantee that it's out there.
Yeah, I guess that's true. But wow. So really, you're very optimistic then, Alan, that 10 years from now or so, we could find something down there.
We could. I give it a chance that it's worth considering. I don't know that it's a majority chance or even like more than a 1 in 4 chance, but
very exciting. Benji, what do you think? Would you like to be the only life forms, or what we might consider, carbon-based units or whatever, in the universe? Or would you rather be accompanied by a panoply of other extraterrestrial life?
I like the idea of having some other people spice things up around here. But I once heard, or I once read somewhere, that perhaps there is life somewhere way beyond, many, many light years away.
Yeah.
But I also read that these are light years away, so things that are happening on Earth, like people many, many light years away, probably can't even see humans. They're probably still looking at the dinosaurs with their super futuristic telescopes over there. Is that true? Is that potentially true?
Maybe a million light years away, but yeah.
It is potentially true. If you are 65 million light years away, then you are receiving light now from us, from when the dinosaurs were just going extinct. So that's the look back time effect that would happen. Now,
we can see galaxies that far away pretty easily at this point.
That's right. 65 million light years is actually pretty darn close in intergalactic terms. In interstellar terms, though, that's still very far away.
That's true.
Just even going 5 light years would take at least 10 to 100,000 years with our current rocket technology. So that's a long, long way away. Not quite 65 million years, but still long enough for us to have completely changed our civilization and possibly even the way we live, whether it's on Earth or elsewhere.
Yeah, right. So every light year is by the name, it's how much it takes light, how much light can travel in a single year. And so the nearest stars are like 4 light years away, which is pretty dang far for human terms, but not that far for light terms. Whereas the nearest galaxies are a couple million light years away, and the nearest galaxy clusters are even farther. And then the edge of the universe is like several billion light years away.
Right. So if there's spacecraft out there and going to, say, the Alpha Centauri system, which is about 4 light years away, they won't get there for a really, really long time. But if there were life forms in the Alpha Centauri system right now, and they were watching our television, they'd be capturing like Picard reruns, which would actually not be too far off.
I'd be good with that.
Oh,
yeah. I would make it so also. That sounds great.
Awesome.
Alan, do you think the Europa Clipper might find Bigfoot?
Man. That would be really big. That'd be amazing. Yeah, more like swimming Bigfoot, fish Bigfoot.
Big fin.
Yeah.
Big flipper.
Oh, that would be great. Big flipper. I would love it if Europa Clipper found Big Flipper. Maybe the Loch Ness Monster.
There you go, Nessie. Nessie the big flipper. Oh, too good, too good. All right, next question.
Am I the next question? I am the next question. All right. All right. So Ben Jordans on Instagram is asking. First, Ben Jordans is thanking us for our content, which I always appreciate. Thank you for listening. And then Ben Jordans continues to ask, how do you perceive the current efforts to mitigate the greenhouse effect? Are you of the opinion that we will succeed in mastering this problem? And if so, how? And thank you.
Wow. Well, the greenhouse effect, right, which is the core physical effect that's causing climate change here on Earth,
right now,
is nothing new. It has happened all over the solar system, on Venus, on Mars, for billions of years. And its effects have been profound and change a lot, right? Now, we humans, when we talk about the greenhouse gas effect, and this is where I'd like to make sure that our audience members are making a distinction, right, between a greenhouse effect, which is an absolutely true scientific effect that happens with atmospheres that have greenhouse gases like carbon dioxide, and whatever political or social decisions or behaviors that are affected by or do affect the amount of greenhouse effect that's going on in our Earth's atmosphere.
Right. Okay. Yeah. So the difficulty is that the greenhouse effect is we are making it worse than
that's right.
Usually.
That's right. It's 100% correct. We are making it stronger, right? Whether or not it's better or worse depends on your point of view. And overall, on balance, too much greenhouse effect is affecting human society negatively. It is harming more people more severely than it is doing good for people. And I think that's something that we should just keep in mind. So the solution to the greenhouse gas effect, if it is, and let's just say for this question, the solution is to return the greenhouse effect to the amount that it was, say, 50 years ago or 100 years ago or something like that, right?
Yeah.
It may take about that much time to reverse, right? If Rome wasn't built in a day, Rome wasn't sacked in a day either. So if we spent half a century increasing our greenhouse gas and thus our carbon dioxide amount and thus our greenhouse effect here on Earth by this much, it may take 50 years at least to bring it back down again.
See, I'm not sure that I agree with you 100% on this. I might have a little bit of a different perspective here.
Ooh.
I think, yeah, so like we were saying, the greenhouse effect as a physical phenomenon has been on Earth for a long time. The issue is just that humans are making the greenhouse gas numbers go up at a rate, like in terms of CO2 per decade or per year, that's faster than anything we've seen before. So it's not that we're at a higher level than anything we've seen before, but that change is faster than anything we've seen before.
That is true. Yes, you make a very, very good point. So does that mean we can change it again equally fast downward?
I think that it's going to take effort and it's going to take a long time for us to get there, but I don't know that it's necessarily going to take us as long as it's been for us to get to this original point, just because like the factors that caused humanity's greenhouse emissions to grow over time from, say 1850 or wherever, the pre-industrial levels that they usually quote. I think because our economy is bigger now and because our pace of innovation is very fast now, we might be able to replace our greenhouse gases with the next thing, whether that's solar, nuclear, wind, whatever, faster than it took us to get from wood-burning civilization to a coal-burning civilization. I think that change might be faster now than it was before.
All right. Well, let's hope so. I don't know. I mean, this is, global warming and climate change and so forth. It's often considered, it's often presented in the media, shall we say, as almost like a generational issue. So I don't know, Stacey, you and I are roughly the same generation, whereas Benji and Alan are like of the next generation, right? So what do you think? I mean, are you, Stacey, as worried about the reduction of greenhouse gases and the rate at which we must do it as, say, Benji and Alan are? That's a question that I would love to just pose to you guys. What do you think?
I feel like I'm more worried about it.
Oh, no kidding.
That's fair.
I'm worried about it as well.
Yeah,
Yeah. Yeah, why would you say so? Please elaborate.
Because what we're leaving for generations to come. I mean, you and I are going to check out before these guys and their kids and their kids' kids and whatever. And yeah, I just kind of think like about the future, you know.
That's pretty wise, I'd say.
And how much we've seen it change since we were kids, Chuck and I.
That's true. That's true.
And where it is now and where it could be going.
Yeah, that's true. Benji, your concern is substantial?
Pretty much the same as Stacey's. I mean, will there be a future for people like Alan and I to conquer?
Yeah, I feel like it's not a question of will there be a future at all when it comes to global warming, but how will the future compare to the present? You know, is it going to be something that's worth investing as much time and we should invest time and effort in now when it's easier to change, when it's easier to prevent these problems than later when it's hard to deal with them.
When you look at these disastrous weather events of recent years, that were predicted back in the 70s if we did nothing, and are happening, and seem to be changing more quickly, you just wonder how quickly that eventual demise could happen.
Yeah, I mean, you look at places like Miami has sunny day flooding now. Just when the tides are high, the sea will lap up onto the streets because the sea levels are higher.
Wow.
Yeah.
Yeah, and perhaps that's the best point of all, Stacey, that you've made. I do remember too, when I was a child, nearly half a century ago, that there were predictions saying that 50 years from now, if we don't change our ways and this and that, these things are going to happen. And they've happened.
Yeah.
They were correct, not because it was some wild guess, some speculation, some opinion, but they sussed out the scientific calculations and bingo, they were correct. And these same folks, the next generation of climate scientists, using the same kind of scientific techniques, are making new predictions for 50 years from now. Why should we now think that those predictions are incorrect when the previous predictions made using the same kinds of methodologies were correct, right?
Yeah, and you look at the IPCC reports and things like that, and you see people saying like, "Listen, we're not necessarily doomed, so don't give up hope." But at the same time, we should
right.
Work harder.
Right. IPCC, for those of you who didn't mention, that Alan mentioned, is the Intergovernmental Panel on Climate Change, which is an organization that's been working as part of the United Nations to study climate change, not to politicize it, not to make any kinds of grandiose, scary statements, but actually to talk about the science. And it's been a very, very interesting read over the past several decades of what they've been doing. Yeah.
And so to get to the last part of the question, will we succeed and how? I think we will succeed. I think it will be hard. And I think it'll take a lot of effort, and I think there will be a lot of damages that we have to deal with along the way. But I think, human ingenuity, the actual will to get things done, like it's sometimes hard to see how the will to get things done is going to be there and how everything's going to get solved. But I have this feeling like, people are waking up to the problem, and the interests that are trying to prevent the problems from being solved or even just muddy the waters are sort of losing steam. So I feel like it's going to
let's hope so, because if they lose steam, then that means they're producing fewer carbon emissions from their steam engine, right? Yeah,
100%.
Well,
unless you have a nuclear powered steam engine.
Okay. Oh my goodness, the time has flown by. We have only time for one last question. Benji, pick one. Tell us what we're doing.
Sounds great. We have a question from Emilio Torres, 2718. How do we go about deciding how big we want a telescope to be? Is it simply the bigger the telescope we make, the farther we'll be able to see into the universe?
Great question. The simple answer is yes. The bigger the telescope we make, the farther we can see. But that's the simple answer. The actual answer is much more complicated than that, because just because something is big doesn't necessarily mean you're able to see far with it. Every kind of telescope is optimized to do something scientifically at the expense of other things. And expense might be the key word. How much does it cost? Right? If we build a gigantic telescope made of glass on the ground and we can see stuff on the ground, that's great. But should we build a smaller telescope out in space where we don't have any problems with the atmosphere blurring our vision? And thus we can take beautiful, beautiful pictures like JWST, for example, taking this Uranus picture and the cosmically cool thing of today, things like
Yeah.
that. So the trade-offs are very important. And so size is important, but it's not going to be the determining factor. It's going to be how much money you can spend on it and what scientific objective you have. So if it were up to you, Benji, what kind of telescope would you make? Would you make a gigundo telescope on the ground? Would you make a smaller telescope in space? Would you make a telescope that looks at some particular kind of object or can do anything?
No, those all sound great. I'd make all of them if I had the money.
Yeah.
Yeah, that's right.
I'm reminded of there's I think it's the Hobby-Eberly telescope that they built in Texas, where they're like, we want to build as big as possible a telescope for our fixed budget, and so they made it out of like a geodesic dome and like a bunch of like segmented mirrors and all these sorts of things, and it works pretty darn well.
Yeah, and it's big. That Hobby-Eberly telescope. That's true. Stacey, do you have a favorite telescope that you'd like to build if you got the chance?
Well, the ones in space fascinate me, and again, another layperson kind of question, but I know there are different kinds. There are the infrared ones, there are the more visual ones. There's the Parker Solar Probe. Is that a telescope?
Sure is.
Help me with that.
Yeah, all of those telescopes, because you don't have an infinite amount of money, have been specialized to do one particular thing. Parker Solar Probe, as its name suggests, does solar astronomy, right?
Yeah, it actually goes right up to the sun and looks at it up close. So it's got the telescope to point at the sun, but also, I mean, you don't usually point telescopes at the sun as the thing, so you have to design it carefully so it doesn't burn out.
Right. So that's a thing. JWST
is crazy.
It is crazy. I'm very impressed by the Parker Solar Probe.
Yeah.
And I mean Chandra, with the infrared with those
Chandra's X-rays, right?
Yeah.
X-rays,
the Chandra X-ray Observatory. Yeah,
that's right. I misspoke. X-ray, and then you have JWST as infrared.
Yes.
Hubble is just a mirror, right?
Hubble is primarily designed to observe visible light, but as a bonus, it's also an ultraviolet light telescope. So it can see ultraviolet light very, very well. It has some detectors that do not appear on the JWST. So it's still doing things that JWST can never do. And maybe
because they're designed for different purposes. Yeah,
that's right. And so maybe that's the best thing for us to walk away from with this question, is to remember that even when you build new telescopes that are super cool, the old telescopes still have value. And if you use them wisely, and if they're worth the money to continue operating them, they can remain just as important and just as cool as they were years ago. And that's a really nice thing to remember. The way we use telescopes is independent of their size. And although we would love to have them to be as big as possible, if we can't, the telescopes are still really cool.
That's a good way of putting it.
All right. Woo! Well, I wish we could answer all the questions that we've been got, but we can't today. But we will do a future episode of Chuck GPT. And the more that we have, the more questions we can answer, the happier we're all going to be, because it's just fun to answer these questions. Let me thank again Benji and Stacey, wonderful team members of the LIUniverse. It's great to have you on the show. We'll do it again sometime. Thank you for your questions, and thank you for your comments, and thank you for everything that you do. Thank you, thank you, thank you, thank you.
Thank you so much for having us as part of this episode and as part of the LIUniverse team. I love being here. I love being on the team. And hell yeah.
Well, we love you being on the team also. Thanks, Benji.
Yay.
I love being part of the LIUniverse.
Hey, thank you. Thank you so much. Alan Liu, as always, thank you so much for being the co-host. It's a real pleasure to have you. Thank you so much.
Yeah, happy to help with these questions.
Yeah. And for all of you out in the audience, thank you so much for being with us today. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.